All right, welcome to the third episode of Author Meets Physics. This is your one-stop shop on YouTube for in-depth critical discussion of recent work in the philosophy of physics. So with me today is Trevor Teitel. Trevor is assistant professor of philosophy at the University of Toronto. And we're going to be discussing Trevor's recent and really awesome paper, What Theoretical Equivalence Could Not Be. This is another one of my, pattern that this show follows, one of my favorite recent interventions in the literature and philosophy of physics. Let me say at the start, just to kind of, I put this in the show notes every time, but I haven't said it previously at the start of the episodes, but I really recommend that viewers read or at least skim the paper before this conversation, because Trevor and I are going to be going into this at a specialist level. And, I think it'll be really helpful to understanding the discussion if you kind of have the paper in front of your awareness a little bit at the start. But hello, Trevor.
Hi, David. Thanks so much for having me. It's great to be
Oh,
here.
yeah. Yeah, of course. Yeah, I'm really thrilled to do this.
Thanks for the kind words.
Yeah. I mean, one of the things that's fun about this is, I get to pick the papers, I get to pick the people come on. So, all the words are genuine. I wouldn't have it on here if I wasn't really thrilled with the work. Yeah, so this is a cool paper. It's a paper that's kind of situated in this literature that had its beginnings, I suppose, with some work from my advisor Hans Halvorsen, his student Thomas Barrett, and then a number of other figures, including Sarita Rosenstock, Jim Weatherall, have kind of contributed to this literature on theoretical equivalence. The idea being to present definitions of what it is for two theories to be equivalent to each other, which is to say, like, as they put it, have the same representational resources at the same capacities to represent physical possibilities. So usually the ingredients that these folks will bring to the table in putting forward these definitions are, on the one hand, the theory's empirical predictions. So theories are required to be empirically equivalent in order to count as theoretically equivalent. And on the other side, they bring the theory's categorical structure, its structure as a category, which is to say the models of the theory and the isomorphisms between those models. Okay, so by way of kind of like launching us into this, so your paper, so there's this tradition of Halvorsen and the following, the figures who followed him, defending these definitions, formal definitions of theoretical equivalence. And there's also a new tradition kind of responding to that, which you are kind of a late temporally addition to. Kevin Coffey, James Wynne, and then Jeremy Butterfield have all kind of objected to these theoretical equivalence views along somewhat similar lines, which is to say, the kind of line of objection goes that these theoretical equivalence people are aiming to determine whether theories are equivalent in the absence of a complete interpretation of those theories, a specification of what they're saying about the theoretical, the meaning of their theoretical terms, the ontology of the theories and things like that. And, this tradition of Coffey, Wynne, Butterfield has kind of raised this line of objection against these theories. So as I take it, you like this line of objection and subscribe to it, but you also think that it can and maybe needs to be taken a bit farther. So let me open the floor to you to kind of like say what it is that you think can be added to these previous critiques of the theoretical equivalence program.
Yeah, and let me also just flag, I think this kind of criticism, really, you can trace it back at least to I think it's 82. So this is nice paper. Anyone who's into this should check it. I think it's called Saving the Noumena. This little old gem Larry Sklar paper. And that's actually how I got into this at first. Was Thomas and Kevin were both, Thomas Barrett, Kevin Coffey were both at NYU when I was there, and we all overlapped. And but sorry, I'll circle back around to answering your question. But the Coffey paper. So one piece of evidence that there's more to be said here is, all the people you mentioned, Weatherall, Barrett, Rosenstock, Halvorsen, like, these are very good philosophers, and they were all aware of the Sklar paper, the Coffey paper, and they didn't stop working on these criteria. So already that should tip you off that there's more to be said, and the sort of trivial semantic conventionality point isn't going to just shut the door there. So the way I understand that point is just this familiar thing, like any sort of what I call in the paper representational vehicle, but sort of like an uninterpreted object. So a sentence, like a syntactic string, some mathematical model. In principle, that can be used to represent anything. There's no like constraint. We might find it more convenient to use shorter strings or whatever to say things, but there's nothing about like the string, say all dogs have fleas, that makes it say, talk about these furry creatures in the world and say of them that they have fleas. So that point is just that one way of putting it is, given any two representational vehicles, understood as these sort of uninterpreted things you might use to represent the world. That jargon is just because I wanted something to cover sentences and mathematical objects. You'll always be able to cook up some interpretation, where interpretation is a mapping from those things to contents, the constraints on the way the world is. You'll always be able to find one relative to which those two vehicles have the same content. So that's how I take the upshot of the conventionality point, this older criticism, that it's really, if equivalence just is, they say the same thing relative to some interpretation or something, then it's going to be really trivial. Okay, so why does that not close the door? Let me say two things, finally getting to your question. So the first is, even granting that point, that still leaves open that there might be some more circumscribed range of interpretations relative to which one of these formal equivalence proofs is going to give you that the two things have the same content relative to every interpretation in this circumscribed class. So even if you might take this point to close the door on like what you might think of as the maximally ambitious claim you might make on behalf of these formal criteria, there's still a sort of scaled back view that they might try to come up with, which is something like, first, independently characterizing class of interpretations. Relative to those interpretations, formal equivalence suffices for, equivalence, what I call semantic equivalence, but saying the same thing about the world. Okay, first thing. Second thing, and this, I think Weatherall, in one of his survey papers says this, is, look, we use this label formal criterion of equivalence because we were proving all these theorems, but we never really meant that to be taken totally on its face. In particular, we always had this qualifier about empirical equivalence. So the thought is that these formal criteria were meant to be part of some sufficient condition for equivalence, where it's formal equivalence plus some notion of preserving empirical equivalence. And of course, empirical equivalence, that can't be a property of a representational vehicle understood as an uninterpreted object, because a sentence or a model just doesn't have any observational consequences. It doesn't tell you anything about the observable or unobservable world. So that suggests that they weren't thinking of the objects of their proofs as just uninterpreted objects, but rather something with some interpretation that tells you something about what we can observe.
Yeah,
that was a long-winded response.
No, I mean that's exactly as much wind as I think the question demanded. And good. That's really helpful. I mean, one of the things that's striking, and you talk a bit about this in the essay yourself. One of the things that's striking about the way that they talk about representation is that they don't talk exactly like, they'll always say not that the two theories are equivalent is a sign that they have the same content or something like that, but that they have the same representational capacities or something, like that they have the same ability to, for any two physical situations, two equivalent theories have equal capacity to describe them accurately or something like that, right? I mean, one of the things that I mean, I guess the thing I was just thinking, well, as you're responding is, like, how do you square that way of understanding what they mean by equivalence with the idea that maybe they have a kind of restricted class of interpretations in mind when they're putting these ideas forward, right?
Yeah, I mean, and I think this is kind of where the rubber shoot. Was there a final thing you wanted to?
No, yeah, that's yeah, that was it.
Yeah, I kind of think this is where a lot of the action will be, because this is a gloss. So when you look at these papers where they're talking about how you get non-mathematical implications out of these mathematical results, it's a common thing you see is this claim, same capacities to represent physical situations. And you said same capacity. I mean, these are, or something, they each can faithfully represent the same situation. So, I mean, these modal words, ability, capacity, these are notoriously, vague and context sensitive. So here's one thing which is not what they mean, but it's something you said, like, given just like one very liberal reading of these terms is that, well, this gloss doesn't really help us at all, because given trivial semantic conventionality, anything has the ability or the capacity to represent any situation, physical or non-physical, just because that's what we learned from that's Putnam's lingo, the trivial semantic conventionality thing. Okay, so that's clearly not what they mean. They must be having some restriction on what they're thinking of when they say capacity to represent. And there's various words that then get wheeled in here. So capacity to faithfully represent, capacity to aptly represent. So I mean, we're going to zoom ahead a bit if that's okay. But like, I think once then we can drill down on these.
Yeah, we can preview where we're going to go.
Yeah. So basically the question is going to be, is there one of these glosses that's going to do the requisite work on behalf of these formal criteria? And I understand that as having two components. Component one is you're going to have to license the following inference. Given some formal equivalence proof, then we can infer, quote, same capacity to, and then insert your favorite thing, same capacity to faithfully, aptly represent. Maybe we have some notion of, you have to somehow mirror the world in the mathematical object. Okay, so that's one inference. Next inference, which is the sort of important for getting the sort of really exciting non-mathematical claims, is given same capacity to represent physical situations, somehow we then get semantic equivalence, that the two things just say the same, quote, say the same thing about the world, full stop. So what I say in the paper is basically there's not going to be any reading of this modal capacity, ability to represent, that's going to give you both of those inferences. So however you persistify it, I think one of them is going to be kind of a non-starter.
Good. So, I mean, I think this is informative too, as a kind of add-on to your answer to the first question, because, I think this gives us a good sense of what you think can be done and should be done beyond the original trivial semantic conventionality based objections to this program. Yeah.
Yeah. Shoot. Because you also asked, how does this relate to the restricted interpretation? Well, exactly in that way. Because so one of the, going beyond the trivial semantic conventionality, you might say relative to some type of interpretations in some such and such class. So suppose you have some constraint on what it is to faithfully represent some physical situation. Well, you might just restrict your attention to those interpretations of the mathematical object. Say interpretations where we never map, some vehicle like a model or category, whatever, to a content in a way that doesn't respect this faithfulness or picturing or whatever your favorite requirement is. Okay, claim relative to that, those interpretations, does one of these proofs going to give you all the way to semantic equivalence relative to those interpretations?
Good. Yeah. And then, through the paper, you consider a couple of candidates of ways that the interpretations could be restricted, kind of ultimately ending up, and we'll get to this in due time, but at this idea of like physically equivalent in scientific practice kind of interpretations, right? Good, but that's for a little ways down the road, I think. Okay, cool. So one of the things that kind of comes up and came up a bit in what you were just saying, and is, I think, kind of central to this stuff, is this idea of like representational vehicles having a kind of intrinsically good ability to stand for some types of propositions rather than others, or something like that. And I mean, I gather that your take on that notion is a fairly skeptical one, and that you think you seem skeptical that there is a kind of important sense in which a representational vehicle can be in its own right well or poorly suited to represent a particular kind of fact or a particular kind of theory or proposition or something. Is that like a kind of like fair?
Not wholesale, I'd say.
Okay.
I mean, I don't want to say, like, suppose you have a map or something. I mean, it seems clear that, like, if I have a map of, I don't know, Manhattan, like, I could also use that to, in some very, like, weird mapping, I can represent, I don't know, some cornfield in the, in Iowa, or pick your favorite location or something. But there might be a sense in which it's sort of intrinsically better to, because again, something like this picture theory stuff, what I am skeptical of is that there's going to be some constraint like this that's going to serve the purposes of proponents of formal criteria. Because again, maybe we ought to have said right off the bat, like, some of the sort of most striking commentary on these formal results have been that they deflate certain debates in the metaphysics of physics. Sort of they're meant to collapse certain distinctions, not quite in the way positivists sought to, but in a sort of more sophisticated way that doesn't rely on some flat-footed empiricist criterion for sameness of content. And the thing I was mainly concerned to do is say that there's no way of understanding this, intrinsically better suited to represent, that's going to let them draw those conclusions. But of course, that's compatible with there being an account that has all sorts of other uses.
Yeah, good. Yeah, right. So yeah, that is a very important kind of piece of context to have on the table, right? So these folks the theoretical equivalence folks are concerned to show things um, like, for example, the one that you consider in your paper, which comes from a paper of Weatherall, Rosenstock, and Barrett, right, is equivalence between the Einstein algebra's formalism for general relativity, which at least on its face doesn't mention points, and the traditional kind of differential geometry, pseudo-Riemannian representation of the theory that does mention them, with the idea maybe that that controversies about the metaphysical status of space-time points become uninteresting when we realize that the real structure of the theory that multiple different formulations of it agree about doesn't require us to talk about space-time points or something. So there's a kind of impulse to deflate away debates that other philosophers of physics are having. Good.
And yeah. This is perhaps, so I run with that example mostly through the paper. I think most of the points I want to make are neutral in that example. But that one, so the context here is, that's my topic. That was my dissertation. So it's like, okay, I'd spent the better part of my 20s, thinking about the substantivalism relationism debate. And then, Thomas Barrett was, in the office next door telling me about this. So the stakes felt very high. So even though this wasn't my dissertation, that's how I got really gripped by this, was rationalizing my life choices up to that point.
Yeah, absolutely. I mean, my undergraduate thesis was on substantivalism, so I feel your
my favorite topic.
I feel your reaction there. Yeah, exactly. Yeah, good. And I mean, another example that has always seemed especially odd to me is I think this is a paper by just Weatherall, the suggestion that like Maxwell space-time with gravitational potential and Newton-Cartan space-time with a curved, with curvature being responsible for gravity, are physically equivalent, right? Another kind of case that seems very like, it's like, boy, that wasn't how my physics professors back in college raised me to think of what's equivalent to what.
And his, I haven't read that paper in a while, but I think his view there's a strange, we can talk about the category theoretic thing, because I think he says that in that case, he's open to the verdict of inequivalence, because he doesn't want to take a stand on, he basically shows, depending on how you couch them as categories, where you have the arrows, you can get one or the other. But I share your view that, they seem very different. Of course, he would say, yeah, they might seem so, but they're not.
Yeah. Good. So let's talk a bit about maybe some of the ways in which the theoretical equivalence folks think about representation that might be a little different from the kind of presuppositions that probably someone of your persuasion or mine might kind of bring to the table, right? So this idea, for example, of like picture theories, right? It seems intuitive that a portrait of my face is going to be kind of like especially well suited to representing my face and not other people's faces. And talking to, I guess, especially Weatherall about this a couple times, I get the vibe that that's kind of how he thinks about mathematical representation in physics, right? So I just a couple weeks ago I had a conversation with him. I was like, well, in this case, we were talking about whether isomorphic models have to have the same representational capacities, which is another view of his. And I was like, well, you know, I could take two isomorphic models of general relativity, and I could stipulate that one of them stands for, you know, like the cocoa in my cup is hot, and another of them stands for the cocoa in my cup is cold. And I can use those to represent those propositions. And there's not a law that kind of prevents you from doing that. And Jim's response was, well, that's not representation in the sense that he means, I think. You know, that kind of like purely standing for a proposition isn't the full sort of representation that we're doing when we represent things in physics. And maybe that theories are supposed to be something more like a map or a picture of the stuff that they are standing for. So I kind of like, you say some things in the paper about the, you know, kind of pessimistically about the prospects of that kind of approach rescuing their view from the semantic conventionality problem. What do you think about that?
Yeah, I mean, I'm open to it. Suppose he said, like, this is how physicists think of how their theories represent that. But again, so the claim that would need to be made is that somehow these strictures on representation are also operative when people are talking about substantivalism and relationism or whatever other metaphysical debate is at issue. So it's like, even if like, this is how he's thinking of representation amongst practicing physicists, it's going to be a big step from there to saying that something about the distinction between whether there are space-time points or not. So in that particular example, the claim would be that we need to, in articulating like what it is for a world to be one with space-time points, we need to limit ourselves to talking, you know, using just these sorts of representational resources, something like these mathematical objects and whatever this picturing stuff is supposed to be. And I'm just not, well, one, I don't know why, and it doesn't, we'd have to, it also just doesn't seem a plausible characterization of how people discussing substantivalism and relationism would view their sort of constraints. So, I mean, trying to, like, well, here's one way to maybe say that is like, think of, see, part of the messiness here is I feel like I don't fully understand this, how this picturing business is supposed to work, but let's,
well, maybe I can say something a little bit further, because this is this kind of points in general relativity example is one where I feel like I get what Weatherall thinks, you know, which isn't to say that that should extend to, you know, Barrett, Rosenstock, Halvorsen, but I feel like I get what Jim thinks about this, which is something like, he's fine to say that there's a substantive question about whether, for example, manifold substantivalism, where points, you know, where you can have different points assigned to different, or to the same, like, you know, metric location in general relativity or something. Like, he's fine with the idea that that's a coherent thing to say, but he thinks general relativity doesn't have the expressive resources to say those things, and that if you want to say those things, you need to supplement general relativity with some extra structure, something like, you know, proper names for points or something like that. And if you don't kind of add that to general relativity, and he feels like the whole argument is supposed to arise because general relativity by itself has the expressive resources to say things about which point is playing which role in the theory. And he doesn't think that it has that capability because like, mathematical structures only have the capability to represent things up to the isomorphisms that characterize whichever type of mathematical structure we're talking about, in this case, Lorentzian manifolds.
That's because that was exactly the thing I was going to say. It seems like however you cash out picturing, it's going to at best give you qualitative propositions and this sort of thing. So propositions like there are some objects with such and such pattern of field values, but it won't give you things like point A has blah field value, whereas point B, whereas of course to get the whole argument going, you need these non-qualitative facts, not about particular objects. But then I don't know, it feels weird. Maybe we need to get Weatherall here so he can tell us more. But like just this claim you just said about like what general relativity, yeah, I'm not seeing, like, I don't know what, like, first I want to hear more, like, what do you name? Like, is it just a name about these certain models satisfying such and such constraints? Like, just for just to get, like, with the whole argument thing. Like, I understand that as a question about if, say, our world had certain features. In this case, you imagine there's a manifold and there's fields on this. Would a certain sort of determinism hold true or not? And yeah, I guess I'm not seeing what, like, how you get from this stricture about what's sort of inherent to the models versus something that maybe goes beyond some understanding of what the models are, what the theory is. How you get that to from there to a response to the whole argument.
Yeah,
of course, he was going on a team means something different by the whole argument.
I mean, that may be like, and it might be that the kind of it might be that there's been some kind of semantic drift in the time since the Norton and Ehrman paper about the whole argument as well, right? So to take an example that you use in the paper, which I think is like super instructive. Your example that, well, a physical theory by itself isn't going to tell you, for example, whether panpsychism is true, right? And if panpsychism is true, then there are all these genuine facts, right? So that the theory kind of like that a total theory you would want to represent one way or another, right? These facts about like which electrons have which kind of proto-conscious properties or something. And the fact that physicists wouldn't be super interested in the question of whether their theory has the capacity to represent this doesn't tell us like that there's no fact to the matter about it or something.
Or that the distinction between what is and isn't conscious is somehow like ill-posed or something.
Yeah, good. Good. Yeah, I mean, so I think what Weatherall might come back and say here is something like, well, I might so he might take the position that points and their specific roles in general relativity have the kind of status that we should think of panpsychic properties as having, namely kind of like ones that the theory isn't trying to represent and like that kind of like shouldn't be taken. So it's like, for example, he might say like, well, if we think that there might be panpsychic properties, would we say that general relativity was indeterministic because the initial data, you know, on some simultaneity surface in general relativity doesn't determine the future panpsychic properties? I think that what Weatherall might say as well, like that might be a sign that the universe has certain non-deterministic features that are kind of outside the bounds of physics, but the physics is deterministic or something. And that was the kind of question that I think he takes Norton and Ehrman to be concerned with in the first place.
Yeah, I mean, so now it sounds like he's making the response is something in the vicinity of, because that's an old response, this thought of, okay, like just mess with the definition of determinism. So like what I call it, and I have a bunch of stuff on substantivalism and the whole argument, but like, so we can do a whole other hour or whatever. But, so call full determinism the thought that like the laws and the state, like either at a time or in some interval, fix everything. Call qualitative determinism, any gnomic possibilities, and given the qualitative state at a time or in, a sandwich, an interval, fix all the qualitative facts. And there's a way of reading this really nice Brighouse.
Yeah,
paper.
Kara Brighouse's paper.
I think it's 97, but and what's 99, there's a Joe Melia paper, I think, right? Holds.
I haven't read that one.
That are exactly going for this line. Like, okay, just grant that there are these different possibilities where you're permuting points around and stuff, but just weaken determinism. Incidentally, I kind of have come around to that kind of view. This is what's called a hexaetus view, and then you try to mess with the definition of determinism. And the most recent thing I wrote on the whole. But I do think there's lots of debates to be had here about why we care about determinism, what the relevant strength is that we should have. And I can tell you. We can do like Ehrman Norton exegesis. I kind of think they were worried about the failures of full determinism. In particular, there's this, infamous quote: "If determinism fails, it should fail for a reason of physics," or something. So one way of reading that is, okay, so we should just leave the failures there, but say they're not interesting because we only care about indeterminism, quote, if it's given some restriction on the relevant properties, something like the ones that the physical theory has. A different reading is that something like, oh no, like these would be failures of full-blown determinism that somehow involve these properties that aren't in our, explicitly stated in our best physics. So we need to get rid of those because the only failure. I also just because we're jumping into the thing I call the physics deference stuff. I do think there's it's a hard thing to say that there's certain class of properties that are in the physical theory, and then there's this stuff that we can sort of siphon off in this sort of principled way. Just to see that, like, of course, values of fields are going to be what you might think of like the exemplar of the property in the physical theory. But then there's a whole debate about what fields are, and the most common view, due to field 84, can we dispense with space-time? It's just that fields are just a certain sort of property or relation that's instantiated by this substantival space-time. And then if you want to junk the points, it's not clear that then you need to tell me more about what the fields are if they're not distributed over this manifold of points.
Yeah, good. I mean, I think this gets to the kind of like, so one of the things so I think one of the reasons why maybe Weatherall's views that we were just talking about might not be fully representative necessarily of the literature that he's in is that it's actually kind of like an issue that's purely about general relativity in its differential geometry formalism and doesn't relate to this stuff about the Einstein algebras version, for example, right?
I mean, there's an old, I never know how to say his name, Rhinoshewitz or something.
Oh, Rhinoshevitz, I think is but Rhino is what everybody is supposed to call him, I think.
But I think he at least, his claim was that you could get a whole argument going even if you're not in the standard differential geometry.
Yeah, that's right. Yeah, that's an interesting, I mean, it's been a long time since I kind of read that paper and I found it kind of hard actually. So it's, but that was grad school. So hopefully I'm better equipped to read things like that now. So yeah, good. Yeah, so let's talk about physics deference, right? So so you're a place where you end up, so you consider these different kinds of like increasingly charitable readings of what you think might be the the restriction, as you said before, that the theoretical equivalence folks are placing on the intended interpretations of the theories that they're talking about. And you kind of end up at this one that you call physics deference, right? So do you want to kind of just real quick explain what that principle is supposed to be, and kind of how maybe the idea would go that that would provide them with the resources they need to say that full stop Einstein algebras are equivalent to Lorentzian manifolds?
Yeah, and we've sort of been tiptoeing around it for probably 20 minutes now. So let's just jump in. But yeah, so the thought was you start with some characterization of, quote, the subject matter of interest to physics. So it sounds like this is what Weatherall wants to say. And that's not meant to be like what, in fact, there's a very crude sort of version where it's what if you polled a physicist on the road, what they would say is of interest to them. That it's not meant to be that. It's meant to be like some idealized deference to, like, quote, the subject matter that physics deals with. So one constraint I lay down on is uncontroversially it's meant to strengthen empirical equivalence. So clearly physicists care about what's observable, but then the thought is it's supposed to go beyond that, because all of these people that are proving these formal results, they explicitly say that they're not trying to be positivists. They want to allow that, say, Lorentzian special relativity might be different than standard SR, or like neo-Newtonian versus Newtonian space-time. Those are different. So they want to allow for some distinctions that go finer than observation. So the physics deference thing is supposed to be, okay, we're allowing for some notion of content beyond what's observable. And then you might think, okay, so what's of interest to physics? Uncontroversially, something like the trajectory, if there are particles, the trajectory of particle, if there are fields, the values of fields distributed over space-time. So that's the claim of, like, physical equivalence. Call them relative to some interpretation, two vehicles are physically equivalent, just in case they say the same thing about whatever this intermediate level of content is meant to be. That's strengthening empirical content. Okay, lots to say there about how we're going to characterize that. Then the physics deference proposal was the thought that, okay, so you hold relative to some interpretation if they're physically equivalent, i.e. they say the same thing about all the subject matter that sort of idealized physics might care about, then they're semantically equivalent relative to that interpretation, i.e. they say the same thing, full stop. And that sounds kind of like what you were, I don't know, I don't want to put words in Weatherall's mouth, but that sounds like in the spirit of what you were thinking he would go for. It's like, well, or actually, maybe he didn't want to say, but I don't know.
Yeah,
that these points aren't of interest to physics, so like whether it's A that has the field value. So does he mean then, okay, so therefore there are no facts of that sort? That would be the physics deference proposal. You sort of, rather than deferring to empirical equivalence as the limits of the distinctions we can draw, sort of positivist style, you have this sort of more nuanced position, but you defer to this sort of this more intermediate level of grain, and that sort of demarcates the limits of what contentful distinctions we could draw.
Yeah, good. I mean, I think, like, again, it would be great if we had him here. I was just talking with him about some of these issues, so I feel like I kind of have a sense of like his zeitgeist or whatever on this. I mean, I think what he would say is something like, whatever uncertainty you have about facts about things like the causal roles of points in space-time or something would be uncertainty you have about whether general relativity is correct, right? Because general relativity, tells you about space-time, and it tells you about it in a way that doesn't have, he thinks, the capacity to differentiate between isomorphic solutions. So if you think there are facts of that sort, then you have to kind of like, I mean, I suppose you could think, yeah, there's an interesting question whether you have to think general relativity is wrong or whether you have to think it's incomplete. To to kind of think that there are real questions here, but I think he would say one of those two things. Either you have to think like, I'm uncertain about whether general relativity is actually a correct theory of space-time, or I'm uncertain about whether it might be a kind of incomplete theory of space-time or something.
I mean, either way, I just have like a million follow-up questions because like then I want to say, okay, so it sounds like what you're thinking, quote, general relativity is some picture where there are facts about space-time, like, because I assume he's thinking there will still be facts like there are, well, I don't know, what do you say that there are space-time points X, Y that have such and such pattern, like field values, even though we can't say point A has this, that, like, would he still say there are qualitative facts that seem like they're quantifying over a manifold of points? Is that the kind of picture he's thinking?
Yeah, it's an interesting question whether he would say that, like, I mean, that's a place where I'm much less certain what he would say. I could see him. I mean, like, so like, if he wanted to say something, I mean, if he wanted, he could say something in a kind of the spirit of this new David Wallace paper about structural realism and say, I don't think that ontology in the sense of first order quantification is a sufficiently accurate way of talking about physical reality. You can kind of like figuratively talk about physical reality using that terminology, but like the terminology that lends itself to describing physical reality is solutions of a mathematical theory. Like, I don't know if he would say that or if he would say something more conciliatory. Yeah, I'm not sure. I don't know.
I see. Well, like the dilemma you gave earlier, I feel like either whichever way we go, I feel like there's lots of things to say, whether it's GR is sort of incomplete versus it's false, or yeah, I mean, it's hard to even tease. But like, for instance, if it's meant to be that there still are these facts about particular points, it just turns out that you have some notion of what physics cares about and or what's internal to the physical theory that excludes them, then I kind of feel like that needn't worry, because that's not the physics deference proposal. The physics deference proposal is meant to say if it's not sort of in this circumscribed subject matter, then there is no distinction there to be drawn. So if it's just that thing, that the incompleteness thought, then I kind of think substantivalists and relationists don't need to be that worried, because they could just say, okay, well, like, this is how I got into this debate. It's like, oh, there's all these familiar denizens of the world, tables, chairs, and then it's like, okay, are there these extra things? Maybe we need a fundamentality qualifier here, but like spatial, maybe they're not points, maybe there's, gunk or whatever, we can go into all the, but like, in addition to material objects, there's more stuff, space, time, are they like a substance or not? And then I could be like, look, I'm interested in that question, whether there's these extra things. And I'm not too fussed about whether you say that those extra things are things physicists need to worry about. It's like, it still seems like you just ask this question about what our world is like, and it seems like you're given two pretty different. I mean, of course, he would resist a lot of that. Anyway, that's the incomplete. And then on the other horn, where it's like, I'm saying like the proponent of GR is putting forward some alternative picture of the world, and I'm presenting this alternate one where there are these points and stuff, but then I just would have a lot of follow-up questions, because I'd be like, okay, so you've told me that I'm supposed to ignore certain features of these models. You've told me the world is such as to be faithfully, aptly, et cetera, represented by such and such solutions. These two solutions don't, this difference is gauged. I'd be like, okay, I still don't really know what the world is like. I have all these questions. So like, for instance, it sounds like you think there are facts, like there are some points or other having such and such pattern of field values. You just don't think there are facts like A. So then it sounds like you have what's called a qualitativist view, where there's the fundamental facts are not about particular objects. And that's a really interesting research program I'm like very invested in, is whether there's a coherent way to make good on that picture of reality. Because a natural thought is, well, how can there be facts like there are, like someone is sitting in the room, but there's no fact. I'm like, okay, so tell me about the person that's sitting. You're like, no. Like, it's just someone is sitting. So then, and then there's a really active thing right now of trying to articulate what a sort of object-free view of the world might be. I mean, Shamik Dasgupta has this whole like algebraic generalist picture and sort of Quinean predicate functories. And there's all this higher order stuff. So Andrew Bacon has a nice paper here. There's all the stuff that goes under the heading of, quote, ontic structural realism. And there's tons of different things there. But it sounds like my follow-up question on the other thing is, it's like, okay, great. It sounds like you have some sort of funky view. I don't want, that's a bit pejorative, but like this alternative picture of what GR is telling us. Tell me more about it. And just telling me about which models can or can't represent, I feel like isn't really getting me very far in figuring out what the world is supposed to be.
Yeah. I mean, I think maybe one place where the physics deference assumption is one that your opponents probably would take on is in the sense that they might think that all of these philosophical questions are superfluous if they don't do work that physicists would rightly be interested in, or like would rightly consider to be kind of in their purview. Because like they might think like the demand for explanations of the stuff that we want to explain, data and things happening a particular way and stuff like that, what have you, the demand for explanations of those things should ultimately bottom out in a demand for a physical explanation of them. And if you want to kind of go beyond that, there's a sense in which like you're going too far, or you're talking about things that are surplus and beyond the kind of resources that we need to give a complete explanation, according to the rules of the scientific enterprise or something, which you might think is like, I mean,
but what did I say? Because that's what the panpsychism case has meant. I mean, there's tons of other things I say about the physics deference proposal, like whether it's well posed, whether it can do the work. But at it sort of culminates. It's like, even if you just grant everything, it just seems false. It seems like there are all sorts of distinctions that physicists don't concern the subject matter of interest of physics and are totally intelligible, contentful distinctions in their own right, nevertheless. Witness phenomenal consciousness or something. But I think there's lots of examples you can run with here, whether there are something like non-Humean laws, moral properties, maybe abstract objects. So like, it does seem like maybe you have some, and the other thing to say is like, there is, of course, you might try to have a picture of the world that just gets rid of all that stuff and somehow vindicates the kind of thing you were just saying about physical explanation being the kind of like the physics deference. But I would kind of like, that's a lot of the thing I'm doing in this paper is saying, look, there's various views you might have in sort of metaphysics, mind, language, that might actually sort of license these non-mathematical inferences from formal criteria. Great. But then it sounds like what you ought to do is then defend those things.
Yeah.
You need to fill in the gaps. And just directly, and because that's where the people who reject the inference aren't going to challenge your proof. They're going to challenge the magic. Sorry, that's again, but like the extra thing you need to get the cool thing out on the other side.
Yeah, good. Yeah, I mean, I that was a point you made that I thought was extremely apt. Which is like the real controversy here between your opponents and the folks that they are trying to kind of deflate the debates of is going to be on the question of whether something like this physics deference view is justified, and like what would be some arguments to justify it, yeah, I mean, I think partly this kind of comes down to a bit of a methodological divide between like a kind of Irvine-centered school of thought and a school of thought that's like centered more in the region of the world where you and I both got our PhDs. You know, in terms of like whether, like to what extent there's kind of, like to what extent it's obvious that philosophy is only on a secure epistemic footing when it is like proceeding very close to scientific reasoning in certain ways, right? And I kind of wonder whether some of the theoretical equivalence people might say, you know, that that's the kind of premise that we're bringing to the table, that like, and so I mean, I suspect that they would think that panpsychist explanations of consciousness are obviously out for similar reasons, maybe at least, or like,
I mean, I'm not a panpsychist.
no, I mean, not, but you and I think both are kind of like part of a tradition that thinks like, yeah, you know, like it's interesting to like, you know, it's like it's not kind of like panpsychism isn't something that I would dismiss out of hand as a solution to a very tough problem.
Exactly.
Right.
And I think that's a good diagnosis. But then again, I would raise, first of all, it's just worth noting that I think you're going to get, it's not just substantivalism relation, and that's just the one I focus on is what I was working on at the time. But like a lot of debates seem like they would fall by the wayside. I'm curious, like what about like Humean, non-Humean laws is another one. But like, what about, I'm just trying to think of things that people in the philosophy of physics community spend time thinking about. Like, so in like stochastic collapse quantum theories, there's this flash matter density kind of picture, which seemed like quite different. But that is a nice diagnosis. But then I would raise the point that it seems like that's the, defending that thing is where the action should be. Not to say that formal equivalence proofs then, given that, would be very interesting, but there's this extra thing that you need to get the proofs to license the results.
Yeah. So on this topic, you have an argument to the effect that we do need to bring in kind of resources that are in a sense external to physics when we're understanding the content of physical theories, right? In the form of, as you put it, kind of ordinary language glosses that are used when introducing a theory and giving it content or something, right? I think this is something that my colleague Laura Ritchie might call partial interpretations of a theory, right? She makes this point in her book on quantum field theory that you know, no theory in physics is ever completely uninterpreted. You know, an example that I like to use to illustrate this is electrodynamics. You know, there was never a version of electrodynamics where, you know, rho didn't represent charge density, right? And we didn't have a kind of like presumption that among the things that we're talking about is charged matter. That feels to me anyway kind of related to the point that you're making, that theories are always put forward with some kind of like English language information that tells you which of the mathematical things you're talking about what. So, you know, maybe you could, to start on this topic, kind of say a bit about why you think that's such a key point against like the version of physics deference that would, if successful, kind of vindicate your opponents.
Good. Yeah. So I'm thinking like that. This is, I mean, there's some steps, but like this is the kind of thing they would likely say in response to the panpsychism case, which is something like, yeah, that's fine. But you're bringing in this word phenomenal consciousness, which is somehow not a okay word. Like the way the example goes, like you somehow make it so that which formalism you adopt for particle physics is going to be bound up with what's conscious and not. And they might say, okay, that's sort of illicit because you're bringing in something sort of external to the formalism. So maybe this would be to grant that they couldn't use their proofs to collapse the distinction between what is and isn't conscious, but to say, nevertheless, the debates we care about, substantivalism, relationism, whether all the stuff on like Faraday tensor versus vector potential and electromagnetism, but into your favorite one, are different than the panpsychism case. Okay, next follow-up question, what's the dis analogy? Well, it's exactly this. It's the thought that something like, there's some notion of how these concepts that are used in formulating physics, words like space-time point, what their semantic properties are, what their metasemantic properties are, that makes them different than words like phenomenal consciousness. So if it turns out that actually, whenever we write down physics, and it sounds like the Ritchie thing is basically saying, yeah, it's sympathetic for this kind of picture, that we're often using repertoire, conceptual repertoire that's external to mathematics.
So the idea then is panpsychism is kind of appealing to this concept of phenomenal consciousness that we kind of have in a way that's like separate from or not coming from the information we get from physics. Whereas you're thinking your opponents should say that our understanding of like physical properties and quantities isn't like that. Is that yeah?
Yeah, exactly. And then so there's two things that happen now. One is drilling down on what exactly they would need to say about space-time point. And then I think there's some messiness just even figuring out what that doctrine would have to look like in order to make formal equivalence proofs still have the kinds of interesting, significant, non-mathematical upshots. And then there's my reasons for thinking actually it's much closer to panpsychism. So let me just say something about both of those. So first, because there's this common thing we use, like, oh, I'm going to like give the theoretical role or the role of some concept in a theory. And I'm thinking like, that's not whatever this doctrine is that they're claiming on behalf of space-time point, can't just be that. Because I'm thinking what they want is some doctrine about space-time point that doesn't just sort of functionalize it in sort of Lewis, Ramsey, that kind of thing, but sort of tethers it to a particular formalism. Because what they want to say is that somehow this proof about the categorical equivalence between differential geometry and Einstein algebras should make us question that whether we had glommed onto a contentful distinction. So whatever the semantic doctrine is, it needs to somehow say that our understanding of what it is to be a space-time point is somehow tethered to the standard formalism of differential geometry in which we couch GR. And there are questions about how that would work. But then I just think there's reasons to think space-time point is not like that. It's much more like phenomenal consciousness where you have some independent grip on it. And I kind of think this is getting back to the Ritchie. Is that, am I saying that right?
Ritchie.
Okay. What it sounds like she thinks, which is this, like whenever we do physics, there's tons of independent conceptual apparatus that we're bringing to bear, in particular sort of concepts, I think very frequently natural language concepts. And there's a question of where those come from. We can talk about that. But yeah, so one thing is, I mean, substantivalism, relationism predates differential geometry. Like you can arguably find something like this even in, I mean, there's pre-Socratic debates about the void, the reality, but certainly Newton, Leibniz weren't, they thought they knew what they were talking about, and it wasn't tied to differential geometry. Now there's messiness here, spatial point, space-time point, we can begin there, but that's one thing. Second thing is just, I think there's independent ways of characterizing the role of space-time point. I know this is something you've thought a lot about recently in this space-time functionalism kind of stuff, but you might, yeah, there's debates about how to define what it is to be a space-time, but we have independent grip on this. The notion, I think we have a grip on the concept of an object. We then, maybe if we have some notion of location, you can define a space-time points of those things that objects are located at, or that the bearers of field values. Maybe you want to somehow tie it to some role in the laws. But I don't think it's like our understanding of the concept seems wedded to physicists drawing a distinction with a particular formalism, which is really, if you're going to drill down on what the physics deference proposal would say, it's kind of, that's what they're going to have to say. And the third thing is just an appeal to, I mean, if you open a physics book, even, or you read work in the metaphysics of physics, it's not like people proceed as follows. You just sort of display a solution space and like, there's the world, or you say like, you know, the world is such as to be represented thusly, or just getting back to the stuff about faithful representation, or these two solutions aren't used to model difference. It's like, no, you know, they write down the math and then they use all sorts of glosses, like representing space-time, representing mass density, blah, 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 blah. So I do think there's good case to be made that space-time point is much more like, there's obviously differences, but much more like phenomenal consciousness, where you can maybe define it in terms of, it's not as if it's tied to some mathematical formalism.
We have a pre-theoretic grasp of it. Yeah, I mean, that's interesting. So what I imagine your opponents might say here is give a kind of like a more spare description of what it is that we're doing when in a textbook we say this variable represents, you know, spatial position, this variable represents mass. I mean, they might say something like, well, the purpose of those kinds of glosses on the content of the theory is to do two things. One is maybe to like make it clear what the theory's empirical content is, which they're definitely cool with, right? And then the other being like maybe to say, what are the inner theoretic relations between the quantities in this theory and quantities in other theories, or something like that, right? So like we say, you know, when we're putting forward general relativity, we say like, hey, you know, these boxes in the stress energy tensor, you know, this one stands for, you know, the rest mass or something like that. That's a way of connecting it to, you know, special relativity, and before that to Newton's mechanics, and saying like which of the entities in this theory have which kind of correspondence to stuff from previous theories or something like that, right? So I mean, maybe so I wonder whether like, I mean, there's two, so it could be that your view is like, that's fine, but that by itself is enough to show that like the problem you're talking about is real. Or maybe like, no, we actually have more theoretical resources to grasp these things other than just empirical content and other theories, that there's some kind of reduction relation or inner theoretic relation to.
I hold the latter, and I would have thought, yeah, like it strikes me as very, I mean, there's of course question of how we come to acquire concepts like an object or phenomenal consciousness and how those come to have content, but of course, I'm thinking like, yeah, we get started somewhere when we're trying to represent the world, and yeah, so I guess so maybe I want to hear more about this, the alternative you're suggesting for them, but it's something like because you're saying that you of course the roles might be tied to earlier physical theories. Where does it all start?
Yeah, I mean, right. So good. So like, I don't think anybody's going to say that this is a kind of like clean cut, the kind of like figuring out what means what in a physics theory is kind of like a clean cut process exactly. But I was thinking that, so a way maybe of defending the view that our only grasp of like, you know, take a particular like theoretical term, like the meaning of mass or something like that, right? Does our only grasp of the meaning of mass come from theories that it's used in? So like the view might go, the first use of the notion of mass that had like content that was deserving the name was Newton's use of it in his mechanics. You know, the quantity that is related in this way to acceleration, right? And you know, has the role of being the measure of inertia and the measure of like the source for the gravitational field. And then so that was a kind of like pure theoretical role, like dubbing of the term.
I just interject one thing quick, because I still think there's the point I raised earlier, which is they don't just need a theoretical role like tied to its role in the laws or something like that. That's not going to give them what they need. They need something that ties it to the particular formalism, right? Which I don't even think is true of, because it needs what they want is that something about this proof between these different formalisms is meant to shake your confidence that you had a grip on the whatever distinction you were. So even if it's say you can, because for instance, again, I'm thinking of like Lewis Ramsey theoretical, like that's all I'm imagining. Like you already have some contentful thing and then you're quantifying out. That doesn't tell you about some mathematical formalism. And all that's to say is I can grant the thing about mass, and I still think there's this particular semantic doctrine here that they're going to need. And again, not the point of the paper. I mean, I do think it's going to be a tough hill to climb, but the point of the paper is like, look, there is a view here that they would need, and so maybe that's true, but you should be. We need to hear arguments for that view. Yeah. Sort of because uncontroversial. There's a particular sort of doctrine about how these terms in physics work that's operating in the background, and I do think just because with the case of. I'm also open to different cases going in different directions. So like this, but I do think the space-time point case, it's hard for me to get into this frame line where it's sort of was dubbed the way mass was. I think like, I mean, there's lots of stuff to say here, but I do think there's something about this notion of I don't know, an arena or like a stage on which the world unfolds, which you can sort of trace back.
Yeah.
So it's hard for me to think that, oh, there was this totally new concept that came along with GR that doesn't have sort of its heritage in these earlier theories. But of course, there's tons to say about theory change across, reference across theory change, blah, 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 blah. There's old thorny topic.
Yeah, good. But so I think I agree with you, right? That like, spatial location or something is a concept that doesn't seem to have arisen from somebody writing up a mathematical physics theory and saying, this is the relationship between this mathematical entity and the experimental data or something, the way that you might say mass arose, right? Like there's a case to be made for that in the case of mass, but maybe like, it seems much more questionable if there's a case to be made for that in the case of location. I mean, just to get clear on the dialectic, it sounds like so the thing you were saying a second ago sounds like even if though they can give this kind of historical route according to which there was an original like previous theory in which the term space-time point gained its meaning purely by some relationship it had to theory's empirical predictions or something. Were you saying a second ago that like there would still be a problem because these relations of theoretical equivalence are supposed to be internal just to general relativity and not to involve other theories? Like Newtonian.
It wasn't even just that; it was also internal to a formalism. Like again,
yeah.
I mean, of course, there's questions about how we're using the word general relativity, but I mean, so there's two. So the dialectic is like, I give them this physics deference proposal, there's tons of messiness and ways to object how that's going to get cashed out. I think there's lots of details beyond what I say in the paper. Then it's like, okay, even granting all of that, so that you grant that the formal equivalence proof, something like the category theoretic criterion, can characterize some well-defined notion of the physical content, this sort of intermediate level of content which we define, which I have some reservations about whether we can do that. I still think there's a problem for this non-mathematical inference from sameness of physical content relative to interpretation to sameness of content, full stop. That's what the panpsychism case is meant to go. Okay, rejoinder, there's something sort of fishy about the panpsychism case that makes it relevantly disanalogous to these cases that they're interested in, like substance timeless relations. And then that's where all this stuff about concepts coming from not these independent conceptual resources comes in. It's meant to say, actually, space-time point is not going to give you what you need. So what do they need? They need two things. They need one of these formal equivalence proofs is going to show you that you have sameness of physical content relative to some interpretation. And I'm thinking if that's meant to then shake our, the second thing they need is from that to semantic equivalence. And I think if you're going to have all of that, where the formal equivalence proof is sort of rendered interesting and not redundant in the whole story, it's going to have to be that this notion of a space-time point is somehow tied to the particular formalism. Can I give you one? This is kind of an aside, but like the kind of case I was thinking is most because again, I struggled to figure out what the semantic doctrine would be. So here's a case that I think kind of helped me see like what they would have to say. This is an exchange between Shamik Dasgupta and Jason Turner on these object-free views. So Shamik Dasgupta introduces this algebraic generalism because there's, again, the response, how could it be a fact? Like there is a person without there being a fact, like a non-qualitative fact. Trevor is in the room or whatever. So then Shamik introduces this framework. He's saying, okay, look, that's when you that inference from there is a blah to A is the blah. That's in the framework of first order logic, existential quantifier. Let me do something fancier. I'm going to introduce this thing, algebraic generalism, in terms of Klein predicate functories. Lots of cool details there, but crucially, there's some operator in there, this cropping operator, that roughly gives you from some predicate some fact that we would pronounce saying that something is F, C is F. Now, this is not an existential quantifier, it's different formalism. And this is meant to show you how there could be a fact that's purely qualitative, like there is something that is sitting that doesn't then presuppose, we can talk about grounding, whatever you want to fill in the story there, a non-qualitative fact, like there's a witness to that quantificational fact. So Turner responded, wait a second, this C operator, it looks a lot like an existential quantifier. You when you tell me how I'm supposed to understand it, you use English words like there are. It sounds like an existential quantifier. It talks like whatever. Introduce. And there's this nice response where he's saying it kind of seems like I can't just say it's exactly like an existential quantifier, but it doesn't have this problematic inference from there is an F to you presuppose a non-qualitative witness to the qualitative fact. And that's a case where it sounds like Turner, it's a very equivalence-friendly thought. But what was going on there is that's a rare case where I think Dasgupta, I don't know if he would want to say this, but it's like he was meant to introducing a concept that was distinctively sort of wedded to this formalism, where it's like this formalism was meant to tell you how you could have a qualitative quantification fact that didn't have this non-qualitative presupposition. So there, it's like there's a case we made that, in fact, whatever we were supposed to understand by this cropping operator, it was wholly wedded to this formalism, how there could be a qualitative quantificational-like thing that didn't presuppose a non-qualitative thing. And then Turner would then, he didn't prove the equivalence result, but it's like he has this meta-semantic principle that's meant to say that you don't actually have a grip on this cropping operator. But however the semantics of the cropping operator was supposed to work to give us a handle on this quantificational apparatus that doesn't presuppose. That's kind of what I think they would have to say is going on with space-time point and so on. Like it's somehow actually tied to some formalism. And then I just think it's kind of implausible that it was like that. But that's the kind of model I was thinking they would have in mind, that it's always like what Shamik was trying to do with algebraic generalism.
Yeah, that's an interesting example, right? So it's like, so they would have to say something like in the differential geometry version of general relativity, you might say like, let's suppose that like I'm somebody who's putting it forward and I'm a substantivalist or something. They might say like you're trying to like define something that you know, you're trying to define a theory that talks about these things, points, and we can kind of show that you haven't succeeded because your theory kind of like your notion of points plays all the same theoretical roles as some other notion that's in a theory that has no points, namely the Einstein algebras picture. Right?
Yeah, and crucially, it was important to introducing the concept that it be introduced via this particular formalism, because again, they're going to then go on to prove results that just engage with the formalism. So the picture of how these theoretical terms work better involves something about the actual formalism, because it's supposed to vindicate these claims about the interest of the formal equivalence proofs.
Do you think it has to be purely parochial to the formalism? In other words, like it's like is the rule for them that it must be that the only things that secure the meaning of the terms are like the mathematical formalism and the empirical predictions, or could they allow that there are like other things that...
Oh, of course they're going to allow. I think they can throw in lots, but there's sort of a twin. What you don't want to do is render the formal criteria redundant. You don't want to say, I mean, here's something you could say, like you need to have, I mean, obviously they wouldn't say this, but like empirical equivalence plus semantic equivalence plus a formal criterion gives you semantic equivalence. Okay, of course, who cares? Because you already have semantic equivalence in, semantic equivalence out. So you don't want to do that. But yeah, so there's a lot, I have a lot of discussion with this, like, you know, they can say it's part of some interesting sufficient condition. But basically, I think there's a sort of two poles of this dilemma where it's like the closer the extra missing ingredient comes to semantic equivalence, the less the formal criterion, it's not doing sort of that distinctive work. It seems like most of the action is on whatever this extra ingredient is. Whereas what they want is that we're using these formal criteria to get cool conclusions out about how our grasp on various concepts. Okay, that's one extreme. But then the other extreme is the closer it comes to empirical equivalence, formal criterion, and then something not that strong, well, then you still need the analog of the non-mathematical inference that's like the physics deference proposal, i.e. the claim that this plus formal criteria give you semantic equivalence. And you need to argue for that. And I'm thinking like the closer the extra ingredient comes to just empirical equivalence plus formal criteria, the more tendentious that inference is going to be. And again, crucially, opponents are not going to challenge the proofs. They're going to challenge this non-mathematical claim that empirical equivalence plus formal criteria plus X equals semantic equivalence, where maybe the X is something like physical equivalence as I characterize it. So again, then the challenge is going to be, hey, tell me more about why I should believe that non-mathematical claim. So there's sort of this you're sort of straddling these two extremes of, you don't want to render the criteria redundant, but you also don't want it to be that it's kind of really close to this positivist thing that many people will find implausible. And
yeah, good. Yeah. I mean, good. So I think this is a really great kind of like big picture look at what you're kind of saying to them, which is ultimately like, the philosophically interesting thing about what you're doing you might say to you know, Rosenstock, Barrett, and Weatherall is like not in the formal results that you've proven, but in the kind of like what's the def or what's the kind of defense you can give of the philosophical presuppositions that kind of underlie the idea that these formal results show what they're supposed to show. And they don't.
Yeah, we don't have to be like, because, you know, if Thomas were here, he would say, what do you mean? Like this is, and I'm pretty, you know, I think this is very philosophically interesting, these results. I'm pretty liberal about what we want to call philosophy, but certainly what's true is that from a dialectical point of view, this non-formal thing is going to be way central in getting these metaphysical conclusions out, because it's like, that's the place where that's going to be the locus of disagreement. So in a sense, that's where we need lots of argument.
Good. Yeah, good. So like what we have in a way is a bunch of work that has like interesting conditional conclusions, namely like if you adopt some kind of principle that bears some resemblance maybe to what you're calling physics deference, then like, you know, here's a bunch of results showing that this theory is equivalent to that one and that one's equivalent to that one and stuff. But the antecedent of the conditional also needs defense, and that's kind of a place where, you know, that's the place where most people are going to get off the boat, if anybody's getting off the boat.
Yeah, it's exactly. So because again, no one would think empirical equivalence on its own gets you there. I mean, there are some who might, but like most people take positivism to have been just a complete dead end. Like as stated, so you don't want to say that, but then there's supposed to be a fancier thing. But again, it's still going to give you these deflationary implications. So there's got to be some extra work, and that non-mathematical inference from, say, physical equivalence plus formal equivalence plus where physical equivalence implies empirical equivalence, as I defined it. That's going to be where the rubber hits the road. And again, you don't want to make it that the formal equivalents are sort of odious. You need to have them still doing interesting work. But you want this inference to not be totally a non-starter. You want there to be plausible things. And I do think the physics deference proposal, as I stated it, comes actually too close to, well, there's messiness about even catching it out, but I do think it's too close to positivism in that it's just, some of the conclusions are going to be really hard to stomach. Mm-hmm. Then there's the restricted physics deference proposal, which is restricted to concepts that have this special property where somehow their semantics is tied to the formalism. Then there's a question of making good that the terms have that property. And there, the inference is almost less problematic than claiming that things like space-time point will fall under the purview of the restricted proposal.
Yeah. Yeah, so good. So in particular, there's going to be a lot of dialectical onus on this question of are the meanings of certain theoretical terms kind of like purely local to the formalism in the way that they kind of need to be for this to, yeah, good. So one of the things I was wondering about, you know, reading the paper, I kind of wondered like, how could they try to defend that picture that you really do need to think about space-time points in a way that's like quite local to general relativity. Like a thing I was thinking is like, maybe they could say something like, well, our kind of pre-relativistic picture of location turned out to be confused enough that it's hard to kind of like, you can't really come up with a correct concept that does the theoretical work you need without like kind of like a big overhaul, right? You know, kind of think of like the overhaul that was needed to come up with a kind of coherent manageable notion of sets, like compared with like the pre-Cantor definition of sets, which, you know, didn't work out, right? So like maybe they could say something like that, like, you know, it's like the pre-relativistic definition of location was confused enough that it needs to be dispensed with, essentially, in favor of the relativistic notion of location.
I mean, this is interesting. And I do think this is kind of, I mean, I don't want to, I should say, like, you should totally have, I don't know, like Thomas Barrett or Neil Dewar. Like, there are a lot of really talented people thinking through this. So I would want to get clear on how they're thinking about these things. Now, of course, this proposal, this sort of more revisionary thing you're floating here, does require that there's some way of making good on this peculiar semantic doctrine, where it's not just role in the theory and the Lewis sort of Ramsey, that type of thing, but somehow wedded to the formalism. And then you need some further claim that,
can you actually, like, can you say just a bit more to clarify why the Ramsey Lewis picture isn't going to be sufficient to you know, to do what they're like? Because I've always, in a way, I've kind of thought of these guys as like a bit akin to that picture. So like, just say a bit more about why that's not.
Well, walk me through it. Like, I just don't see. So I think of the Ramsey is like, you start with some description of the world, you have some proposition in mind, and then what you start doing is you start ramsifying out particular term. You know, and then you end up with this. You know, you still have the O term. I mean, we don't have to use OT, but like you have this long string of, you know, first and higher order quantifiers for and then there's certain things, you know, in the world, these, you know, whether relations or whatever, you have some contentful distinctions in mind, and then you're thinking there's a thing that blah, 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 tied to, I don't know, maybe you have causation, maybe you have some laws or something as your O terms. Okay. Question, tell me about the Ramsey sentence that's going to make it that, like, what's the Ramsey sentence that's going to make this term, when it's have its content wedded to something like a formalism? Like, I don't think of the Ramsey sentence as getting in on the action at the level of the representational vehicle, but their proofs are at that level. Does this make sense?
Yeah. No, I get it. I mean, I wasn't thinking it was kind of like going to be exactly a Ramsey sentence, you know, because it's like, if it was that, they would just be working in those terms, right? But I was thinking maybe they would say something like, well, like some feature of a class of mathematical models gets its semantic content by the relationship it has to, you know, the parts of those models that represent the, like, you know, O language stuff, which is to say the, like, observational content of the theory, right? So it's like you know, like the metric maybe in general relativity kind of gets its content from like being a mathematical structure that kind of has this particular role within the theory, and part of that role is being related to the numbers in the theory that represent what the proper time measured by a clock moving from here to here would be, or like what the proper length measured by a particular measuring rod would be, or something. Right.
Yeah, and crucial. And you're thinking this is not going to be true, because notice it needs to be whatever the Ramsey sentence is, it can't apply to the Einstein algebra solution space. So what's the, because remember, they want to say that, you know, you thought you had some difference, some distinction that you were glomming onto, and then I do this proof, and that shows you that you were wrong, because these things are equivalent. So I can see how it could work. Sorry, this is really helpful. And this part happens way too quickly in the paper. I should have spent more time on this. But so what you're thinking is like you could have this Ramsey sentence. Maybe this isn't, I don't want to put words in your mouth, but you could have this
Ramsey sentence analog, right?
Yeah,
like
yeah.
It's kind of like mathematical Ramsey sentence.
Ramsey star sentence, but it's going to have crucial, like some of the conjuncts are going to be things like is represented by, where that is something peculiar to the differential geometry formulas. You're going to end up with some sentence that, say, picks out the, like something like a metric tensor. But again, it can't just be things like um, yeah, I don't know, like the thing that's related to the stress energy tensor, because that would all be true also in the Einstein algebra thing. So it needs to be somehow
Oh yeah, I was
up on
thinking.
features of the differential geometry formula.
Oh, sorry. I was thinking that this would be a way for them to, for your opponents to say, like, here's how the theoretical terms in general relativity, which is to say, like, the formalism, which is equally well presented as a theory of Lorentzian manifolds or a theory of Einstein algebras, right?
Okay, but then we're doing something different. So, because then I feel like, because remember, this semantic doctrine was about how there would be what you thought you meant by space-time point, such that learning about this equivalence proof will then make you think you don't have a contentful distinction in mind when you talk using space-time point. Why is that? Because you are using some content that is not preserved between the differential geometry thing and the Einstein algebra thing. Therefore, once you learn that these physical equivalent, therefore semantically equivalent, you have to abandon your sense that there is some contentful distinction here. So whatever the semantic doctrine is for how they're thinking of space-time point, it needs to be something that isn't true in both. So then there's a separate question about what the vision of the world there. So maybe we should come back to that, because we still haven't. There's a question you asked like 3 questions ago that we should get back to. But yeah, then there's a question of what the content is that is such. Once you present this equivalence proof and you say these are semantically equivalent, then there's a question. Okay, so what is the world like? And then it sounds like this is what you're presenting here. Well, it's this sort of Ramsified qualitative type thing.
Okay, that's super clarifying about the way that you were thinking about the role of the like Lewis Ramsey stuff here. I mean, I wonder, I kind of feel like the thing that they would want to say about space-time points isn't something like you had a way to talk about them that was parochial to the like differential geometry formalism, and now that we've shown you that the differential geometry formalism is theoretical equivalent to the Einstein algebra's formalism, you should forget about those things because they're parochial to the differential geometry version. I was thinking that like maybe they would say something like, you thought you had done a good job of spelling out a theoretical term space-time point in the differential geometry formalism. You were mistaken, because the only theoretical terms that you're kind of allowed to define, that you're capable of defining using mathematical models, are the ones that are kind of invariant under mappings between mathematically equivalent versions of the same theory. And like
totally, but it still needs to be plausible. I totally agree with that difference. But that doesn't sort of discharge the onus to make good on this semantic doctrine, even if it's false. That was meant to be not wedded to the differential, because they still need to make a claim that what people are talking about in this substantivalism relationism debate gets the thumbs down by this criterion you just outlined. So it better be that there's some semantic hypothesis about what people. So I mean, maybe it's true of what people thought they meant by space-time point. I think it's implausible. This was getting back to your thing about Cantor, and but we can come back to that. But yeah, so even if it's, so then they say, oh, because these are physically equivalent, you have to jettison the notion of space-time point so understood, because it was cutting across, it was marking a distinction that wasn't contentful. It was analogous to font choice or something like that, where you thought there was some difference in them. Okay, great, but you still have to say that the thing you're deflating is what people in the substantivalism relation debate were talking about. That's, and I think it's kind of implausible, but that somehow our grip on that debate is wedded to some particular formalism. And then on the physics deference proposal, it's even stronger. It's that some idealized deference to physicists would, it would be them, that those idealized physicists marking out some contentful distinction. between one formalism and the other. Does that clarify?
That does 100%, right? Good.
Okay.
So they need to show maybe not only that there is like some concept of space-time point that gets deflated away by their results, but that it is the one that gets deflated away is the one that the metaphysicians
100%
talking about. Yeah.
Well, it better be that. So this is going way back to the beginning about. So you're not talking about every interpretation. So you're not doing the trivial semantic conventionality thing. So you're making a claim about some sort of more restricted range of interpretations, maybe the ones that mesh with the physics deference proposal. Okay, it better be that the interpretations people in fact are using fall into that class, because again, there are lots of cool conclusions you can draw out of these proofs, but the ones that I was most sort of strident and trying to resist were the ones that were deflating these debates. So it better be that the interpretations that you're saying are the ones that these people, in fact, the ones at issue.
Yeah. Okay. That's cool. All right. Wow. All right. Well, this is great. I'm so glad that we a couple of times during these discussions, I've had this experience of being like, oh yeah, like now I get something about this paper that I
ought to have been clear.
So that's super helpful, Trevor. It was really great. Okay. So there's a kind of like quite big picture thing that you comment on a little bit in the paper that I just kind of like wanted to hear some more of your thoughts about, which is this issue about like, can we really treat mathematical models as the kind of things that have content in something like the way that sentences express propositions or something like that, right? You expressed some skepticism about that in a couple of points in the paper. I was thinking like footnote 3 of the paper. It's maybe you can tell me. It's always been kind of, I don't know, like it's always been kind of intuitive for me to think of mathematical entities as like content bearing things in physics, the way that they're used, right? Like I've always kind of felt like, okay, so what I'm doing when I just put together like Newtonian gravity or something like that as a theory, like one way of thinking about that might be to kind of like write up a bunch of sentences in some formal logical language or something. Another way to think about it might be to say, well, I'm kind of like writing up these solutions to these equations, and I have some quantities like physical properties, mass and distance, things like that. And I say like to like quote unquote assert the truth of this solution to the theory is just to say, well, the real world distance quantity takes on the values that the mathematical distance quantity takes in this solution to the theory, and the real world mass quantity takes on the values that the mass quantity takes on in this solution to the theory and stuff like that, right? So it's like there's something kind of weird about that, but it also seems to me to be a lot like the way that solutions to equations are used in physics. And it does feel like there's this kind of parallel between like presenting you with a solution of a theory and like asserting some big sentence or something like that, right? Kind of like communicating to you some propositional content.
So just to clarify, I think you can totally hook up at some point a solution with some content, but I think the mode is kind of different the way it works.
I see.
I don't think because it sounded like, I mean, there's a separate sort of nominalism, Platonism, but I don't think that matters that much here. I think whatever you think about the abstracta and that kind of thing, you can get in on this difference. I want to hear more about the thing you said, just how you're thinking about it. With you get, the number the equation assigns is the number in the physical. Like, I'm not sure what the physical.
Oh yeah, okay. That
This-
was some loose talk for sure.
I mean, and of course, lots about quantities, and there's going to be messiness here. But let's. But I mean, the rough picture I have in mind is you still can get a content associated with some solution, but like, but the solution will just be this, this tuple, and maybe the points of the manifold are not even, they could be anything. They could be like, as long as they have the, cats and dogs and whatever other objects you want to throw in there, satisfying some structure. And then you'll say something like, well, like there's some similarity. I mean, there's lots of interesting stuff about modeling and how that works, but it's like you're saying something about this object, however, whether it's an abstract object or not, whatever you want to think, like, and saying that it's in some respect such as to be hooked up with this content. Maybe it's something about similarity. Of course, we might need to. Oh, wait.
Oh no! It's like I've always thought that the idea that there could be similarity between like mathematical entities and like physical entities, it didn't make much sense to me. Like what makes more sense to me is the idea that like mathematical entities can be symbols for like propositions about physical entities or something. Like
so I agree, the propositions we're interested in will definitely be about the world, like not representational stuff. I guess I'm thinking you have the way you get that association is different than with a sentence. Like sometimes like, so I'm thinking in the case of the solution, of course the whole second bit of the paper is like, oh, we need lots of resources to affect this association, something like natural language glosses, but it's something like these, you use resources like space-time, these points are objects associated with blah, and then then you might say things about which features of the model you want to junk out, and but actually I cut you off. Say more about the disanalogy you were thinking about.
Oh, I mean, no, I feel like I feel like I got across the thing that I was meaning to get across. So yeah.
I mean, does sound like there's a difference. I haven't yet put my finger on where we differ, if there is a difference. So maybe say one more time what you're.
Well, let me return. Sorry, I'm quickly grabbing out the paper here. So the thing that seemed to me like it might be a source of a difference of opinion between us is footnote 3 of the paper, where you say you think there are problems with lumping sentences together with mathematical objects. You say, in particular, I'm skeptical of the common practice of treating mathematical objects as things that, like sentences, might be or fail to be semantically equivalent to one another. When we use a sentence to describe the non-mathematical world, we do it by using it to express some proposition or content. By contrast, when we use a mathematical object, like a set of mathematical models to describe the physical world, we do it by saying something about that object and the non-mathematical world, usually highlighting some salient aspect in which the two are similar. So the thing that I was thinking was like, I mean, maybe, some people say that, like, Ron Geary or something think that the relationship between mathematical models and the physics stuff they represent is like some kind of similarity relation. Like I was saying, that's always seemed kind of implausible to me. And it's always kind of seemed to me like what we're doing in physics is using math as kind of like signs or symbols for propositions. And like we can do that in ways where the the structure of the mathematical objects, like, has some kind of interesting role. I mean, I guess the
Can I say one quick?
Oh yeah.
Actually, no, go. I do think there might be this analogy here between claims, like when you write down an equation, like solve the like the field equation. There's something like that versus writing down like a solution space. and the way in which the equation expresses, say, this law, versus when you say the solution space is meant to say like something about like this is what these gnomic possibilities are, because but sorry, finish what you were saying. That's
yeah, I mean, I was so a thing that I'm kind of like bringing to this, which is a paper that you cite approvingly in your paper, is the Calendar Cohen thing about scientific representation being like not so different from other kinds of representation, right? Like, and by the way, I think that I think that paper, if one reads it and kind of like internalizes it, really speaks in favor of the way that you think about like how a theory of physics gets its content, and
100%.
we bring to bear like all these kind of like previous concepts that we had, like space-time point, perhaps, when we're kind of giving our theory some content. But yeah, I was thinking
very approvingly. I mean, they have all like this particular sort of Gricean medicine, but I think you can take their take-home sort of bumper sticker message without some of the specifics in the paper. But yeah, I totally agree.
Yeah. I mean, like the thing that I took to be kind of like compelling about it is, other forms of representation are maybe like parasitic on representation in thought. And, like there's a particular kind of thing that is the content of a thought, which you might say is like a proposition. And I can use words as signs for those things, or I can use like mathematical entities as signs for thoughts, for the contents of thoughts. And, a lot of what we do in physics is like doing that latter thing, using solutions to some equations as signs for, a particular kind of like really heavily structured content.
I mean, I think I agree with all of that. So that's why I'm trying to think about exactly where we're differing. Like, because it also sounds like you agree with the thing I said, that like when you have, so if you write down some solution, you have to say something like this thing is supposed to represent space-time in order to associate that solution with some content. So like that's what I was envisaging when I said like you say something about.
Yeah, I mean, right.
Maybe it's the word similarity that's the problematic word here.
Yeah, I mean, right. So like similarity, the similarity thing, like I said, it seems implausible to me, but the kind of, I mean, I guess like it sounded like you were saying that there's not a strong parallel between the way that we use words or sentences and the way that we use mathematical like structures or solutions or something.
Well, I certainly think they get us hooked up with content. So I didn't mean to say like they're altogether different, but I do think there are differences. And this comes up in the paper because I introduced this notion of a representational vehicle that's meant to encompass a syntactic string in a formal language, or a natural language, a string in a natural language, or like or something like a category of models or a set of models. Even though I do, but the criteria, this is actually something, again, I ought to have said right off the get-go. Like there are two types of these criteria. We've basically spent this whole time on the ones relating the kinds of things you find in physics, like mathematical, but like tons of the work is also on informal language, relating sort of theories in formal languages, like sets of sentences of first order logic or something like that. So the way the paper goes, I sort of split those up. I said most of the time in the stuff we've been chatting about, but I do think the sentential ones raise their own problems. So I just wanted to, I guess maybe now I'm thinking maybe this, but I don't know, we could spend more time on my psychology when I wrote the footnote. But I think it was like I was feeling like, oh, even though I'm introducing this blanket term, there are still, I don't want to suggest that sort of the way things go with models is exactly in concert with the way things go with sentences. I also do think that it is odd that the formal criteria often, these two things are just discussed together, the sort of category theoretic ones and the sentential ones. I think they're quite different.
Yeah.
I still think the sentential ones, if anything there, I think the case against them having non-mathematical implications is much cleaner. And that's why that's like a much shorter bit in the...
This is like the Morita equivalence stuff.
Morita equivalent, but also this old Quine thing, this Gleamore stuff.
Yeah. Yeah. No, right. I mean, right. Um, yeah. Yeah. Yeah, I guess that part of the paper was, I didn't end up having a lot of questions about it. So, but it was a cool part of the paper. Did you want to kind of like,
No, it's totally, I mean, who knows whether anyone will actually read this. I mean, I think it's true, but of course, if you had Thomas or Neil or Weatherall or Rosenstock here, I'm sure they would tell me I was wrong. I think some of the messiness is some of the people doing the sentential stuff. And I say this in the paper, it's not clear to me that they saw themselves as doing anything other than proving theorems. It's like interesting results in pure math and logic. So the paper is very deliberate from the outset that the target is only how you might fill in the gaps to a non-mathematical, sort of an interesting, significant non-mathematical upshot. And I have I have no comment about results to the effect that such and such vehicles do or do not stand in such and such formal relation. But it's not.
Yeah, they're right about that.
Yeah. So the case for the and then the reason I spent more time on the physicsy case is that's where there was this substantialism relationism thing got deflated. So I do think that where the non-mathematical implications have been most prominent is about the non-sentential criteria, like the category theoretic one.
Yeah. Yeah, interesting. Yeah, I mean, I think that's yeah. Like I think that like I said, right, that was the part that kind of where I had the most like questions about it anyway. So that
but it is striking, like the sentential criteria on their face don't like that section. It feels like I must like it because it's the stuff I'm saying. It's like the criteria, like at least just taken at face value, they don't even preserve material equivalence, let alone
right.
semantic. Like at least the regimentation of like I think an example is this is from an old Sklar thing, like all dogs or all lions have teeth.
All lions have stripes and all tigers.
Those aren't even materially equivalent. There is a dog and there is a cat might turn out equivalent on these four. So like there, it seems really hard to get non-mathematical implications out, given that on the interpretations we care about, it seems like these formal criteria don't even preserve material equivalence, let alone necessary equivalence or semantic equivalence or whatever stronger thing you might throw in there.
Yeah. I mean, right. It must, at least for those things it must rest on some pretty heavy presuppositions about what is required for, two sentences to really have different meaning or something. Like it must be that there's a very close to positivist picture of what's required for that in order.
100%.
Yeah.
And that section is, it's sort of too quick, but as you know, journal articles, you have to end up cutting stuff.
I mean, you had a huge amount to say in this paper. It's a very,
but it's like there's a bunch of replies that go through that you might throw in. So like, first of all, you could tack on empirical equivalence. I don't think that's going to get to the heart, even though it deals with Sklar's cases. It doesn't get to the heart. But then you might have some sort of holism. There's issues about whether it's a necessary condition because Gleamore only thought they were. Anyways, I don't know if we want to just march through all that. I don't think it would be that.
I mean, it's the part of the paper where I felt it was like, it was the much more straightforward part of the paper.
Okay.
Where whereas the stuff we've been talking about is stuff where I for example, I could see viewers of the show coming in like having a little harder time understanding those parts. So that's one of the reasons why I thought it would be more interesting to kind of focus.
I also think there's a cool I mean, for me, this is just evidence that there's lots of the issues we've been talking about words like space-time point and their properties. There's still lots of work to be done drilling down on how all these messy topics. Is that reactions, like when I presented this paper, have been, you're like one of the rare people who doesn't have one of the following, I'm hopelessly confused, or this is all kind of trivial and obvious. So like you're somewhere like, oh no, it's there's lots to object to, but it's not one of those two extremes. But the fact that it can be quite polar, I do think is just evidence of the thing you were saying, that there's people think about some of these issues, these foundational questions about representation and what the significance of these models in really quite different ways.
Yeah. I mean, I think there's no question that like, you know, somebody like Weatherall brings quite different kind of premises to the table than you'll see from most like most even philosophers of science, like in a lot of other programs, right? And it's, you know, yeah, it's although I mean also like Weatherall is an interesting figure because like I also think that he has more like a lot more overlap with kind of like, I don't know what you want to call it, like East Coasty philosophy of physics than you know, you might expect given his pedigree, right? So it's like it's yeah, there's all, I mean, I could talk for like days about like all the different kind of like interrelations between different schools of thought and
most minutiae and how things change as you go westward or something.
Yeah. I mean, I think there used to be a much more kind of like easily demarcated set of schools of thought in philosophy of physics than there is now.
Wherever it was raining and where it wasn't, and so
yeah, I mean right. That's exactly right. That's one of the dividing lines has become much blurrier.
That might be of interest for like a very small subset of who knows.
Yeah, I mean, like, you know, whatever. This is something that I used to, it's something I used to hold forth about when people were like coming as prospective grad students. But this has been so great and like so rich and just awesome. Like, I don't want to take your whole day up, Trevor. And we should get to just a couple things that were kind of like the questions that I like to ask to end an episode, right? So one is, you know, having written this paper, I guess it sounds like you closed up work on it 2 or 3 years ago now. Like, are you in any way kind of a different place with respect to the kind of subject matter you covered? Like, are there further developments in your thought that have happened since then? Is kind of the first of these kind of ending questions.
This feels like the answer everyone is. I mean, I still agree with.
I mean, yeah, like that's a kind of like. So one thing I have not heard yet is somebody being like, I was wrong, but
yeah, no, I do stand by what I said, and again, I want to emphasize the. I mean, I do think it's tricky to fill in the gaps, but the main sort of thing I was trying to drive home is how to get the non-mathematical conclusions out, there's going to be a lot of extra work that still hasn't been done, and I certainly do stand by. I do want to just reiterate a thing I said earlier. Like, there's lots of really talented people who would vehemently disagree with everything I said. So it would be cool to have one of them on. I know I haven't talked to them much, but I know Neil Dewar, Thomas Barrett were telling me that they were going to write a reply telling me why I was wrong about everything. So I mean, I'm excited to read that. My sense is the way they're thinking about it is they think actually there's even these equivalence results there's then input from there into the sort of what we were calling like this theory independent, you know, these glosses. But it's hard for me to see how that would work if the glosses are natural language glosses, because it's hard for me to think how like natural language word its semantic is gonna be tied to equivalence proofs between formalisms and mathematical physics. But again, so anyway, just to flag that. But yeah, I do stand by what I said, and I am still. So I haven't. This was a sort of side. Main thing I do is just sort of first order metaphysics topics, but I've thought a lot about just the particular case in the space-time case, because I write a lot about subentitleist relationism is clear at this point, and there the way I like to set up issues tends to be pretty non-standard. So like a very common reaction when I'm talking about the whole argument or something is, you know, you haven't. You know, the paper's half done and you haven't yet talked about which solutions do or don't represent the same possibility and what is or isn't differentially, blah, 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 like all these questions about gauge. because my general view is that actually like those questions, not that they're not interesting, but they, I'm quite fond of pointing to figures that can agree on all these questions about representation. They can agree on all these questions about which solutions are or not gauge, which differences are or not mere gauge, different, blah, blah. And then still there's a whole host of other metaphysical questions left open. And then, so my tack is generally just to just frame things directly in terms of the non-mathematical subject matter. So in the case of, say, the whole argument, I just think people would already get off the boat here, but I think determinism is going to be this modal question, and we can just talk directly about what the gnomic possibilities are given the laws of GR. Are there ones that are merely hexaetistically different, say, when we permute points around, without doing this sort of ascent where you first talk about how we represent these possibilities and which of these things we do or don't use to represent. So people, I could go on about this for hours, but I'll just, so I just finished a paper, it's on my website, called How to Be a Space-Time Substantivalist, which is defending this sort of hexaetist view I like. It's my latest, I think it's like I finally have a view where I'm pretty happy with where I ended up. But anyway, there's an early section there that I added trying to head off this thought that, I should just be framing things in terms of diffeomorphisms and solutions. And so it's trying to justify the tack of just directly talking about the non-mathematical stuff from the outset, and how, so explicitly saying, at least in this case of space-time, how these questions about gauge aren't going to get you, and there's not even an easy way to get from that to the relevant, say, anti-hexaetist claim that's going to rescue determinism. But I don't know if that answers your, but yeah, so I'm still thinking these are maybe under a different guise than I was when I wrote this paper.
That also gets a little bit to the second kind of ending question I have, which is, what kind of would be like, if do you have any new projects that you're working on now that you'd like to kind of draw viewers' attention to, right?
Oh, okay. Well, yeah, I would say that I'm really excited about that paper. It's on my website, which is trevorteitel.com, this How to Be a Space-Time Substantivalist paper. So it's defended a certain stripe of substantivalism. And it's picking, because I had written a few other things on the whole argument in substantivalism, relationism. And those just sort of framed things in the way I think they should be framed, which, as came out earlier, I think is quite different than someone like Weatherall is thinking about what the whole argument is and what its significance is. But the most recent one is the first time where there's been some footnotes where I've said things about why I'm framing things in the way, but where I have like a long section devoted to just that topic. The other stuff I'm working on, I just finished a thing that's about this question that I think the whole argument raises, which is about different strengths of determinism, which I think is a much more general question in metaphysics than just about, in the particular, the threats of the non-qualitative threats of determinism you get from the whole argument. So I could say more, but yeah, that's the main stuff I'm thinking about. I'm also working on some stuff on counterfactuals, which is not much more circuitously related to the topic of today.
Cool. Yeah. Well, and maybe I'll add, if I had to recommend another paper of yours to the listener, it would definitely be your the one on rates of change, which really like rocked my world. It was like, it's one of the most like, I don't know, it's one of the papers where I've had most the effect of like reading it and being like, oh, I'm so depressed about whether this problem could possibly be solved in a satisfactory way, which was cool. This is your paper with David. Wait, how do you pronounce his last name? Is it Biles?
I think it's Builes.
Okay,
yeah. I really like that paper. Yeah, we were friends in grad school, wrote that. And the stuff I was just telling about with determinism, we were writing this thing on persistence, different views of endurantism versus perdurantism and metaphysics of persistence, and how they relate to these questions of non-qualitative determinism. There's also like an older thing, if people are interested in the whole argument, I have an older paper called Holes in Space-Time, Neglected Essentials, which is sort of a precursor to the recent substantivalism paper. But anyway, thanks for the plug. That paper is just mind-blowing, I thought. Oh, cool.
All right. Well, thank you so much, Trevor, for joining me here and making for another really fun for me anyway episode of this show. I appreciate it so much, and
Thanks so much for having me. It's been a blast and nice to see you again.
Oh yeah, awesome.